timer or counter, Intel 8253 or 8254. Intel 8253 or 8254 is a timer or counter programmable interval timer, which is also known as Intel 8253. It solves one of the most common problem in any microprocessor system, that is the generation of accurate time delays under software control. Instead of setting up timing loops in a system software, the programmer configures the 8253 or 8254 to match the requirements, which initializes one of the counters of the 8253 or 8254. The pin diagram shows here. It has the 24 pins, and starting from D0 to D7, and the clock, output, gate, ground, VCC, read and write, chip select, A0, A1, clock 1, clock 2, gate 1, gate 2. And it consists of read signal, write signal, chip select signal, and address lines, two address lines, A0 and A1, and gate, out, and clock. And this shows the blocked architecture of the programmable interval timer, which consists of data bus buffer, read write logic, control word register, and counter 0, counter 1, counter 2. It has powerful command called readback command, which allows the user to check the count value and programmed mode. It provides 3 independent 16-bit counters, each capable of handling clock inputs up to 10 MHz. All the modes are software programmable, and the 8254 superset of the 8253. The 8254 uses HMOS technology and comes in a 24-pin plastic package. Intel's programmable counter or timer device facilitates the generation of accurate time delays. When the 8253 is used as timing and delay generation peripheral, the microprocessor becomes free from the task related to the counting process. This minimizes the software overhead of the microprocessor. And this shows the control word register, counter 0, counter 1, counter 2, and the last one is mode word or control word. And as we see, address line A0 and A1 with the combination of read bar and write bar, which are active low signal. Based on these combinations, a particular function is being selected. For example, read write control supports 5 control signals, namely read bar, write bar, A0, A1, and chip select. The functions of the first 4 control signals are tabulated in this figure. The address lines A0 and A1 selects the counter 0, counter 1, and counter 2 or the control word register. Based on the read bar and write bar signals are enabled at a particular time, determines that be selected counter or the control word register can be read or written into. If read bar signal is 1 and the write bar signal is 0 and A0 A1 is 00, then the counter 0 is loaded. The same A0 A1 is 0 and the read bar is 0, write bar is 1, then a read counter is activated. Similarly, the next one. Then 8254 programming, if you take, it consists of 8-bit control word, namely D0 up to D7. The first bit D0 is BCD, that is it selects a BCD when it is 1, and M0, M1, M2 determines the mode of the operation. It consists of 5 modes, 5 operating modes: mode 0, mode 1, mode 2, mode 3, mode 4, and mode 5. And D4, D5, RL0, RL1, D6, D7, SC0, SC1, RW 0 RW1 is a read write control logic, and SC is the select counter. Which counter is select counter 0 or counter 1 or counter 2? And if the M0, M1, M2 based on the input combinations 0, 0, 0, 0, 0, 1, accordingly the mode is particular corresponding mode is selected. The read write logic, whether the read operation or write operation to be performed, that is decided by the combination of D4 and D5. For example, combination is 0, 0, then the counter latch command is executed. If it is 0, 1, read write least significant byte only, 1, 0, read write most significant byte only, and if it is double 1, read write LSB first followed by the MSB. And select counter, if it is 0, 0, counter 0 is selected, 0, 1, counter 1 is selected, 1, 0, counter 2 is selected. If it is 1, 1, read back command. And the modes of operation, as I already told, mode 0, mode 1 up to mode 5. Mode 0 means interrupt on terminal count. Mode 1 is programmable one shot. Mode 2 is a rate generator. Mode 3 is square wave generator. Mode 4 software triggered strobe. Mode 5 hardware triggered strobe. Mode 0 and mode 1 are same in the shape, that is non-periodic signal, and mode 2 and mode 3 are almost same in the shape, that is periodic, and mode 4 and mode 5 are same in the shape, which are non-periodic. The mode 0 we are seeing in the diagram. In this mode, the output is initially low after the mode is set. The out remains low even after the count value is loaded in the counter. The counter starts decrementing the count value, after the falling edge of the clock if the gate input is high, and the output is like this. And in the mode 1 also, the mode 1 programmable one shot, this operation is called programmable one shot because in this mode 8254 can be used as a monostable multivibrator. Duration of the quasi-stable state of the monostable multivibrator is decided by the count loaded in the count register. The gate input is used as a trigger input here. And the mode 2, this mode is called as the rate generator or divide by n counter. If n is loaded as the count value, then after n pulses, the out becomes low only for one clock cycle. Count n is reloaded again and again. Out signal is initially high. Also, a low signal on gate can force the out to high. Mode 3, square wave generator. In this mode, 8253 can be used as a square wave generator when the count n loaded is even, then for half of the count, the out remains high. For the remaining n by 2 pulses, it remains low. Mode 4, software triggered strobe. This operation is termed as a software triggered strobe because after the mode is set, the out goes high. When a count is loaded, counting down starts. On terminal count, the out goes low for one clock cycle and then goes high. Mode 5 is a hardware triggered strobe. This mode of operation, a strobe signal is generated in response to the rising edge of the trigger input. Also, this mode can be used to generate a delayed strobe in response to an externally generated signal.